Hello. I'd like to have a little mini lesson here on the concept of equivalent resistance. So as we dig into analyzing and drawing and talking about circuits, there's two major ways that we can wire things, which is series and parallel. And the battery only senses an overall resistance. It doesn't see what else is out there in the field. So I like to term this as what the battery sees, or equivalent resistance. So I apologize for the poor, I think it's about the lighting, but anyway, this is take two. It's the best I can do. And, oh boy, this thing is right in the way. All right, so these resistors are wired in series, and it's 1. So if I'm an electron, I have to go through the first and the second and the third. All right, so for a series circuit, if you want to get this in your notes or just remember this, right? Series R total equals resistor 1 plus resistor 2 plus resistor 3 plus ... Who knows how many you have out there, right? That's your formula. So in this case, it's 10 plus 15 plus 35, right? I have a calculator, but I don't need a calculator for that. So my total equivalent resistance for this problem would be 60 ohms. Okay, moving over to the right, I've got a 50 and a 10. I look at those. Those are also wired in series, so they just add up. That is also 60 ohms. Now you also have this worksheet posted with today's. I'm not expecting you to do it. I just want you to pay attention and move along with us. All right, so I'm just going to move up one. Okay, this is the other way that I might wire a circuit. So if I'm an electron coming in this way, I get to this junction. I now have a choice, and I can go through circuit 1 or sub-branch 2 or circuit 3, right? Before it was and, now it's or, right? And so electrons behave like humans, and they take the path of least resistance. So more will flow in the lower branch, but all three of these are equal at 10 ohms, right? And so I better give you the formula, right? So in this case, for a parallel circuit, it's 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3 and plus ... right? So there is your formula for finding the equivalent resistance in parallel circuits. Right? So in this particular case, it's going to be 1 over R total equals 1/10 plus 1/10 plus 1/10, right? Which is equal to 3/10 of an ohm, right? But that's 1 over RT, so RT is the reciprocal of that. RT equals 10 over 3 equals 3.3 ohms. So notice, if I have a series circuit, they add up and the resistance gets larger. If I start adding more branches in parallel, my equivalent resistance goes down. Right, so now I'm at 1/3 of where I was before. Very different. All right, I guess what we can do is do this. This is one of those frame of reference kinds of tricks. That's pretty good in the shadow. That's the best. Okay, I'm just going to pick up my green pen. And so what have I done here? Oh, teacher is always trying to trick me. So all I'm going to do is to a green dotted line right there. Have I changed that problem at all? No, I've just changed how I'm looking at it. It now looks like two resistors in parallel in series, right, with that other 5 ohm resistor. So I guess I can do this part in green, right? So just analyzing this part on the right, 1 over RT equals 1 over 20 plus 1 over 5, right? This is equivalent to 4/20ths, so 1 over RT equals 1/20th plus 4/20ths, it's 5/20ths. So RT, right, taking the reciprocal of both, 20 divided by 5 is 4 ohms. Am I done? No, that's a partial, right? That's just the equivalent resistance of these two resistors in parallel, right? So I had a 20 and a 5 together wired this way. They have an equivalent resistance of 4 ohms, which is in series with the 5. So the grand total, I'll pick up my other writing utensil, right, is 9 ohms, right, adding the two together. And that's what the battery sees. All right, speaking of what does the battery see, I'm just going to slide over to this one, try to get it in the shadow. Oh my God, what's going on here? I got all kinds of stuff. I've got a battery. Well, that's fairly common. I have to have something powering my circuit. I've got a switch to turn it on and off. And for the purposes of this course, there's no internal resistance to either of those. So I have a lamp symbol. If I don't recognize that, I should look at my symbol list. And it's labeled as 5 ohms. And this is just a resistor at 200 ohms. So how are those wired? If I'm an electron, I have to go through the 5 and the 200. So that's wired in series. I look at my formula. All I have to do is add them. I ignore the battery and the switch. 205 ohms. That wasn't that bad. All right. What happens on this? This is where it pays to learn how to read a schematic. Oh my gosh, there's a lot going on, but this is actually a trick problem. And we'll just leave it at that for today, right? So I've got a 6-volt battery. That's fairly common. I've got a switch to turn it on and off. What is this device right next to the battery? That is a fuse, right? That's protecting the circuits. I'm sure some of you have blown a fuse in either the house or the car, right? And that's just to protect the wires and you. All right, that's its purpose. So then looking, I have a 10 ohm resistor. It's in series with these 3. But I'm looking at this one. There's no symbol. So that's just a wire, right? In real life, that's a short circuit. So electrons are always going to take the path of least resistance. So all the electrons are going to go down this short circuit or wire, never going down these two, right? So I don't even have to do any math. My answer is 10 ohms. All right. So hopefully you now have a better understanding of some of the symbols of circuits, the difference between series and parallel, how to handle those equivalent resistances. All right, you always have this tutorial to go back to if you need it. And of course, I'm always available to ask questions of. All right, hope that helped. There we go.